So let's now have our case number 2. Okay. So for our case number 2, we will have our buckling along or about the y-axis. Okay. So let's visualize it. Okay. So I think let's use this color blue. Alright. So you have here your buckling masyado pa rin malaki. Okay, that should do. Okay, so you have your buckling about y-axis. And your deformation about x-axis will be this one. Kasi meron kang brace sa gitna, di ba? You have here your roller support sa top and your bottom is fixed support. So, your deformation, if you have your buckling about y-axis, should be like this one. So, magkakaroon ka dito. And dito. Okay? Now, to visualize that, again, you have your sa data mali. Okay, so we'll have about x-axis, and your deformation will be like this one. Okay, kasi meron ka dito, remember meron kang brace dito, di ba? Okay, again, this is 3 meters and 4 meters. Now, so sa upper part, this will be our case 2. Consider natin specifically the case 2 dun sa buckling about y-axis on the upper part. So your L will be equal to 3 meters. Okay? And both segments or both ends of the segment, kasi this sa upper is roller and or say, let's say simply supported yung upper support ng first part nung column mo, and the bottom part, which is yung intermediate brace mo, is also serve as pin support. So ang mangyayari dyan, both ends of the segment have 0 moments. Okay? So ibig sabihin, both ends are pin supported. Therefore, your KY will be 1.0. Okay. Now, so for your slenderness ratio, your KY times LY over RY, so that should be 1 times 3,000 over your RY. Again, that is 66.8 millimeter. Okay, so let's write here 66.8. So this will be equal to 44.91. Okay. Now case 3. So for your case 3, so you have the buckling about y-axis of the lower part. So ito yun. Okay. So your L will be 4 meters. Okay. And looking at the lower part of your buckling about y-axis, sa upper part is pin support kasi naka-intermediate brace tayo. And dun sa lower part is fixed. Okay? So therefore, your KY is 0.8. Okay? So the slenderness ratio, KY LY over RY, will be equal to 0.8 times 4,000 over 66.8. Si RY ulit ang ginamit natin. So we have here 47.904. Okay? So compare natin yung tatlong slenderness ratio. So you have first 48.69696. Second one is 44.910 and the third one is 47.904. Okay. So ibig sabihin yung pinakamalaking slenderness or the critical slenderness ratio na nakuha natin is yung 48.696. Okay. So gagamitin natin the critical slenderness is 48.696. Okay. So for our step 2, we have to compute for the buckling stress or F sub E. Okay, so remember the formula for F sub E is equal to pi squared times E over KL over R squared. So that is equal to pi squared times 200,000 over 49 or 48.696 squared. Okay, that should be equal to 832.43 MPa. Okay, so for the step 3, okay, so let's compare this to 0.44 times Fy. So again, your 0.44 Fy, your Fy is 345 because we used A50. So you have 0.44 times 345. So this should be equal to 151.8 MPa, okay, which is less than 832.43. Okay, comparing to this one. So ibig sabihin, our FCR is equal to 0.658 raised to Fy over Fe times Fy. Okay, so this is equal to quantity 0.658 times 345 over 832.43 times 345. Okay, so this is equal to 290.06 MPa. Now, we now have our value for FCR, so you can now proceed to step 4 to determine the nominal capacity. Okay, so the nominal capacity is Pn. So Pn is equal to 16,800 times 290.06 over 1000. So this should be equal to 4,873.0 kilo Newton. Okay, so we now have our value for our nominal capacity Pn. So we can now compute for the capacity or design capacity in AST and LRFT. So step 5. So for ASD, so this is Pn over omega C. That is 4,873 over 1.67. So that is equal to 2,917.9 kilo Newton. Okay. Now for LRFT, so you have phi sub C times Pn. So that is equal to 0.9 times 4,873. So this will be equal to 4,385.7 kilo Newton. Okay, so you have here our values for our safe load for ASD and LRFT. Alright?